If you want the plane to climb, just pull the yoke back. If you want the plane to descend, pull the yoke back even more. To understand how an aerodynamic stall occurs, we first need a few terms out of the way. Looking at an airfoil, the chord line is the straight line connecting the leading edge to the trailing edge of the wing. Now for this example, let's imagine that the wing is traveling forward. The equal and opposite air striking the wing is called the relative wind. The angle formed between the relative wind and the chord line is what we call the angle of attack. As the airflow above the wing gets pinched, it causes a type of Venturi effect, increasing air velocity and lowering air pressure, while the downward deflected wind below the wing increases air pressure, thus creating lift. As the angle of attack increases, the amount of total lift also increases to a finite amount. Eventually, the angle of attack becomes so large that airflow can no longer make the rapid change in direction needed to follow the top contour of the wing and start separating. This is the point we call the critical angle of attack. The wings are still producing lift at this point, but just not enough to maintain level flight, as the wing is in an aerodynamic stall, or just stall. One important thing to note about wing stalls is that it will occur at the same critical angle of attack regardless of airspeed, weight, and load factor.